Sine law applications. C1. A quick note on sine law. Well, sine law is a vast topic and has been covered in every book in many different ways. So I was thinking how to get around this and what kind of perspective should I give to my students so that they take something more than what they are already getting, right? So here are a few tips on working on sine law and really understanding what sine law is. So let's start with a general triangle and we'll call this triangle ABC. Okay, let's say this is my triangle and I'm calling this triangle ABC. So this side is A, this is vertex is B, and this vertex is C, right? So what we will do is we'll drop a perpendicular from A to BC. Now this is a perpendicular, and so we have this 90 degrees, and let this point be D. So as we know, always in a triangle we label the sides as lowercase letters of the vertices. So the side BC could be written as A and side AC can be written as B. Side AB will be small c, lowercase, and let us call this height of this as h, the perpendicular. Correct? Now, what is sine law? In any triangle which is given to us, we say sine law is ratio of the sides length with the angles on the opposite side, right? So here we can write sine law as A over sine A equals to B over sine B equals to C over sine C, right? So basically if you have to see, you have to see the opposite side, which is in this case A over sine A, B over sine B, C over sine C, right? So it really doesn't matter what kind of triangle it is. Basically, you have to see side opposite to the angle and take the ratio, and that ratio is constant. Always think like this ratio is equals to something constant. Think like this. That helps to solve problems, right? Because now I can write what is A. So A is k times sine A, B is k times sine B, C is k times sine C. So it helps to solve many problems if we look into this equation in this manner, right? So that is one thing which is very, very critical, and I find it very helpful in solving problems involving sine law. So that is, this ratio should be given a value, a constant. So what we're trying to say that the ratio is constant in any triangle whatsoever. That's the first point. Second, you will realize that sine law has its own limitations. If I give you only sides, let us A, B and C, can you solve a triangle? I don't think so, right? So there are two particular situations where sine law cannot be used. And that is, if I give you side, 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 all the sides, just the sides, A, B, C, right? Say, well, this is my triangle where A, B, C is 1, 2, 3. Now find the angle A, B, C. That will really become very difficult to do it, right? You can't do it. So if we are given side, 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 then we can't really solve a triangle using sine law. Another situation where we cannot solve a triangle using sine law is if we are given inscribed angle. That means side, angle, side. What I'm trying to say is, in this ratio, if I give you C, A and angle B, that means I give you C, A and angle B. Do you see that? Then also I can't solve this triangle. So any two sides, if I give you A, B and sine C, I cannot solve this triangle. I need at least one of the ratios so that I know what K is. Do you understand the concept here? So if in a triangle, I'll give you any combination, like if I give you these two sides and that angle, I can't solve the triangle. I need to know one thing as a whole, which is equals to K. Unless and until I know at least one pair of side and angle which are opposite to one another, I cannot use sine law. So in general, we can say if SSS, that means we given three sides or side included angle. So that means included angle, right? Included between the sides. This A is in between the sides, right? In that case, sine law cannot be used. Okay, so you cannot apply sine law. To our rescue, we will use cosine law, right? That will be the next section where this kind of situation will be solved. But in all other situations, sine law can be used, right? So the other situations are when we are given two sides and any angle. So that is not the included angle. It could be on this side, that side, or any side, right? What I'm trying to say, it could be, or if we give you two angles and a side. If we give you two angles, let us say these two angles, and even the side which is not opposite to them, let us say this. But you know the third angle, because the third angle will be 180 minus these two angles. So when we give you two angles, it means all three angles are known to you, right? Then any side can work, correct? Or if I give you two angles and a side in between, so let me write S here in between. In that case also, you can solve the triangle, right? So these are the three cases where actually sine law can be used, correct? So these three cases are good for sine law. So this is sine law, this is for sine law. So I thought this is a very important information to share with you. Now another thing which is very important to understand here is that sine law is actually derived from basic trigonometric ratios, right? These are basic trigonometric ratios. What I'm trying to say that when you use the primary angles in the right triangle, so those concepts can be used here also, correct? To solve problem when you're using sine law, you can actually, if at times required, you can use the primary trigonometric ratios, which are normally used in a right triangle, correct? Since you will realize that sine law is derived from the basic trigonometric ratios. Well, let me show you what I'm trying to say here. Okay, so what I'm trying to share with you is that if you look into this triangle, then what is h equals to? Let's look into this height. So we can find height. Let's say we are trying to solve this triangle. So we can find height in terms of sine b, right? So what is sine b? Let us say sine b is equals to h over c, right? H over c. Now that means height is equals to c times sine b, right? Now if you look from the other side, what is sine c? You say, well, sine c is equals to h over b. Okay, that's fine. This goes to h over b. In that case, height is equals to b times sine c. Is that okay? So height is equals to b times, just cross multiply. So we have the same triangle and we just drop a perpendicular. Then what we see is that we can write height in terms of c sine b or in terms of b sine c. But it's the same height, so that means these two things are equal, right? So now, so we can say from here that c sine b, so let me now come here back to this place. So we say, well, c sine b is equals to b sine c. b sine c. Perfect. Now let me write it in the form of sine law. That means what I will divide is I'll do cross. I'll divide both sides by sine b and sine c. In that case, I get what? C over sine c equals to b over sine b. Now do you see? That is sine law, and this is a constant for any triangle, correct? This is a constant, correct? So the derivation of sine law is actually from the basic trigonometric ratios, correct? So I could have solved this triangle, found b, c, angle c, or side b using basic trigonometric ratio of the same triangle, or I could apply this formula, which is sine law, and found my answer, correct? So the idea here is to share with you that it is not that sine law is different from the normal trigonometric ratios. Some people, oh, now we have to apply sine law. It's not that. It's like, sine law is a convenience, right? It is like cutting down on these 3 steps. It's like doing the problem more simply, right? But this is like the basic way of solving problems. So the basic way still works, okay? With this, we start some work on sine law applications, right? I will take examples from nature. I love walking, and some of my examples are from Humbert Train. So we'll share those with you, okay? Thank you, and I hope you enjoy this journey of sine law applications with me. Thank you and all the best.